Welcome to Algorithm video series. Today, let's write a Python program to find the index of the first occurrence of a given target in the sorted list containing duplicate elements. Here, input of our program is a sorted list of numbers with duplicate elements and a target element, and output is index of the first occurrence of that given target element. For example, here we can see a sorted list of numbers with duplicate elements, right? Here target is 30 and index of first occurrence of 30 is 2 here. That's why output is 2. First occurrence in a list of numbers means the position or index where a particular number appears for the very first time in the list. For example, in this list, if I want to find the first occurrence of 10, then that is at index 0. It appears only once. So here first occurrence and last occurrence is same, that is at index 0. But if I take element as 40, 40 appears at index 3 and 4, right? So if we talk about first occurrence of 40 in this list, that is at index 3. Here last index of 40 is at index 4. First occurrence is the index or position where a particular number appears for the very first time in the list of numbers. To find the index of first occurrence of the given target element, we can use linear search algorithm. As we know, in linear search, we'll search in sequential order, right? That's why in linear search, we'll get the index of the first occurrence of the target element easily. For example, here we can see that. But here in the problem statement, it is mentioned that the input is sorted list of numbers with duplicate elements, right? So when we are using sorted list, it is better to use binary search algorithm to find the target element and also to find the first occurrence of the target element. But here we can't use normal binary search algorithm because in normal binary search, as soon as we find the target, we'll return the index, right? But here the element may appear multiple times because duplicate elements are allowed here. And we want to find the first position. So we need to modify binary search algorithm. So what we need to do is, first we need to find the middle element, then compare the middle element with the target element. If it is equal, then don't return the index like we do in the normal binary search. Here we need to store that index in case it turns out to be first occurrence of that target element. And we need to continue search in the left side to see if there is earlier one. If find another target on left, update the result. If not, mid remains the result. When middle element is our target element, what we need to do is first we need to store that index because it can be the first occurrence of that target element. Next, we need to continue search in the left side to see if there is earlier one. If we find another target in the left side, then we need to update the result, that is index. If not, mid remains a result. And next, if mid element is not equal to target element, then we need to check whether target is greater than middle element. If it is true, then we need to search in the right side. Otherwise, we need to search in the left side, like normal binary search. What is the difference between normal binary search and modified binary search? Here you can see, when middle element becomes equal to target element, in the normal binary search, we'll return its index and we are done. But in the modified binary search, we are searching for the first occurrence of the target element. When the middle element equals to the target, there are two possibilities. First one is, it is the first occurrence of the target element in the list. And the second possibility is, it is not the first occurrence of the target element in the list. That means, the same number appears earlier. So we have to look to the left because here input is a sorted list with duplicate elements. That's why in the modified binary search algorithm, when target becomes equal to middle element, we'll store the index first and next we'll continue search in the left side. Here duplicate elements are allowed. Finding target once doesn't mean it is the first time it appears. So that's why store the index of the middle element and keep searching in the left half to see the same value appears earlier. Next, let's take an example. Alright, here we have list of numbers, sorted list of numbers, and these are all the index. Okay, first step is we need to find the middle element. Here low plus high truncated division 2. So we'll get middle as 3, right? So this is our middle element. Then compare the middle element with the target. So let's take target as 30. So middle element is equal to target. Here it is true. In this condition 30 is equal to 30. So target is found. Now what we need to do? We need to store the index of this middle element because it can be the first occurrence of our target element. So let's take a variable and we'll store its index. Next we need to continue search in the left side. So here to search in the left side I need to take high equal to mid minus 1. So this is our search area now. Again find the middle element. 0 plus 2 truncated division 2. So middle is 1. So this is our middle. Compare middle with the target element, that is 20 is equal to 30. Here it is false, right? Then compare whether the target element is greater than the middle element. Here yes, 20 is less than 30. So 30 is greater than 20. So what we need to do? We need to search in the right side of the middle element. So now low becomes mid plus 1. We'll do the same thing with the normal binary search, right? Now this is our low. Next again find the middle element. Now this is our search area. So again find the middle element. 2 plus 2 truncated division 2. So we'll get 2 as the middle element. So this will become our middle element. Then compare the middle element with the target element. Here 30 is equal to 30. True. So when it is true, that means we found another target element. So what we need to do is we need to update this variable now. We need to store this index. Here index is 2. So answer is 2. This variable will store the index of the first occurrence of the target element. So now update this. So here answer is 2. Next, what we need to do? We need to search in the left side. So I'll take high equal to mid minus 1. Here when high equal to mid minus 1, high becomes 1. Here low is greater than high. So now we need to stop the binary search. Here this variable holds the result, that is the index of first occurrence of the target element. Okay, let's take another example. First step, find the middle element. 7 truncated division 2, so we'll get 3, that is the middle element. Then compare middle with the target element. Let's take target as 22. Compare the middle element with target. Here it is true. So what we need to do? We need to store this index and we need to search in the left side. We need to check whether 22 is already present in the left side or not. So here to search in the left side, I need to take high equal to mid minus 1. Again find the middle element. Low plus high truncated division 2. So we'll get middle as 1. So this is our middle element. Compare middle element with the target element. 11 equal to 22. No, it is not. 11 is actually less than 22. So we need to search in the right side of the middle element. So low becomes this, mid plus 1. Now again we need to find the middle element. So here 2 plus 2 truncated division 2. So we'll get this as the middle element. Compare this middle element with the target element. 22 is equal to 22. True. It is true. So now we found another target element. So we need to update this index. We need to store this index now. Here again we need to check in the left side. High becomes mid minus 1. But here low is greater than high. So we need to stop the binary search. So answer is 2. Let's take another example. Here this is a list of numbers. Target is 111. And initially low is this, high is this. We need to find the middle element. So low plus high truncated division 2. So we'll get 3. So this is our middle element. Then compare the middle element with the target element. Here it is not equal and target is less than middle element. So when target is less than middle element, we need to search in the left area, right? So high becomes mid minus 1. Now high is mid minus 1. Here we need to repeat the same thing. We need to find the middle element. 0 plus 2 truncated division 2. We'll get this as our middle element. Compare the middle element with the target element. Here target is 111 and middle element is 111. It is equal. So we found our target. Now what we need to do is we need to first save that index because it can be our possible answer. Then we need to search in the left side. So to search in the left side, I'll take high as mid minus 1. So now high will point to this. Okay. Now we need to find the middle element. Low plus high truncated division 2. So we'll get this as middle element. Compare the middle element with the target element. Here 111 is equal to 111. So here we found another target element and we need to store this index now because this is the first occurrence of 111 now. So save that index. Next, we need to search in the left area. To search in the left side, I'll take high as mid minus 1. Now high point to minus 1. Now here you can see low becomes greater than high. So we need to stop binary search now. The first occurrence of target element, that is 111, is 0th index. Let's take another example. Here target is 444. So first find the middle element. So this is the middle element. Compare the middle element with the target. 222 is equal to 444. No, it is not. And here target is greater than the middle element. We need to search in the right side. So low becomes mid plus 1. This is our search area. Now find the middle element here in this search area. 4 plus 7, that is 11. 11 truncated division 2. So we'll get 5. This is middle element. Compare the element with the target element. Yes, it is true. Middle element is 444 and target element is also 444. So it is equal. So we need to store that index here. It can be the first occurrence of our target element. So store that index and search in the left side. Right? So here high becomes mid minus 1. So now high will point to this. Now this is our search area. Find the middle element. So we'll get this as mid. Compare middle element with the target element now. Here middle element is not equal to target element. So what we need to do? When it is not equal, then compare whether middle element is less than target element. Yes, middle element is less than target element. We need to search in the right side. So low becomes mid plus 1. But here we can see low is greater than high now. So in binary search, when low becomes greater than high, we need to stop. So here we need to stop and here our output is 5. That is the first occurrence of the target element, that is 444. Okay. So let's write the program. As I said, we can use linear search algorithm to find the first occurrence of the target element. No need to do any changes to linear search algorithm. Just use linear search algorithm. How many elements? Let's take 5. And here because problem statement says that it is a sorted list of numbers with duplicate elements, I'll enter elements like this. Then I'll enter target element as 30. Then we'll get index 2. Because linear search algorithms search in the sequential order, we'll get the first occurrence easily. So no need to modify the linear search algorithm. So next, let's talk about binary search algorithm. This is the normal binary search algorithm. When target becomes equal to middle element, we'll return its index. So let's save this and execute this and we'll see whether it works for the sorted list with the duplicate elements to find the first occurrence of the target element. So let's enter 5. Alright. So now I'll enter 20 as my target element. So we'll get index as 2. But actually we need output as 1 because the first occurrence of 20 is at index 1. That's why I said normal binary search doesn't work here. Because when target is found, it will return its index. But here we need to search for the first occurrence of the target element, right? So here we need to modify this binary search algorithm. We need to change this part. When target is equal to the middle element, what we need to do is we need to store that index first. For that, let's take a variable. Initially, I'll take its value as -1. And here, when target is equal to middle element, then store that index. Then continue search in the left side. For that, I'll take high equal to mid -1. Right? Next here, we need to return answer here. Here, this algorithm returns the index of first occurrence of the target element if target is present in the given list of numbers. If target is not present, then we'll return -1. So that's why initially I'll take answer equal to -1. If target is present here, then it will return the index of first occurrence of that element. Otherwise, it will return -1. Okay, now we are done. Let's save this and execute this. Let's enter 6. I'll enter 40. 40 is found at index 3. That is the first occurrence. Alright, so this is how we can find the first occurrence of the target element in the given sorted list of numbers with duplicate values. So that's it for now guys. Thank you for watching. Don't forget to subscribe to my channel. I will meet you in next class. Till then, take care.